I'll note down the attendance at the end. Huh? I'll note down the attendance at the end. Now we'll continue with the content. No attendance. Remind me at the end. Okay. Hold on. Okay. The screen sharing is visible. Can see the notes. Can just somebody confirm? From B division also. From one of the student from 4th A or C and one from B.
Visible, sir.
Okay, thank you. So fluid kinematics, as we have completed first module or introduction, and we have studied some part of the fluid statics, like you have studied manometers, wherein fluid is at rest. Okay, and some things about pressure you have studied. So now we'll study the kinematics part, and kinematics part only with respect to fluid, because in this subject only we are discussing with respect to fluid. And I have taken this from VTU e-learning. Okay, the source is from VTU e-learning. The notes is available there also. You can download this also. Okay, so whichever content looks good for us, we will be using that content. Okay, so this content, if you are not finding out, no, I will upload it in your class groups, respective class groups. No need to worry. Okay, so as we have discussed in the introduction classes, what is fluid mechanics? Already we have discussed this. Okay, so it is the study of fluid when the fluid is in motion. But what we are doing is, here we are not considering the forces which are making the fluid to move, We are just studying the properties of the fluid when it is in motion. Okay, we are studying like we are measuring its velocity, we are measuring the acceleration. These things we are doing, but we are not considering the force which is making the fluid to move. Okay, if you consider the force acting on the fluid, then that becomes fluid dynamics. Okay, so in this kinematics, we will not be talking about the forces which are making or which are creating the force on the fluid and making it to move. Okay, so here our distinction or the discussion will be limited to the properties of fluid when measuring the properties or understanding the properties of the fluid when it is in motion. Okay. Yes, so you can see here fluid kinematics. Fluid kinematics refers to the features of fluid in motion. Okay, fluid features means it is any of the property. It only deals with the fluid motion of it only deals with the motion of fluid particles without taking into account forces causing the motion. Okay, without taking into account forces causing the motion. Okay, so consideration of velocity, acceleration, flow rate, nature of flow, flow visualization are taken up under fluid kinematics. Is that clear? So we are considering velocity, acceleration, flow rate, nature of flow, flow visualization. These things we are considering. Okay. A fluid motion can be analyzed by one of the two alternative approaches. So famously we have two approaches, Lagrangian and Eulerian. Lagrangian and Eulerian. Okay. So in Lagrangian approach, a particle or a fluid element is identified and followed during the course of the motion as demonstrated in figure 1. So this is the figure 1. Okay, you can see here it is mentioned that a particle or a fluid element. So that particle will be continuously followed during its course of motion. So if this is the particle 1, so it is moving from here to here, here to here, here to here. So it will be followed throughout. Followed throughout means wherever it is moving, okay, the properties will also be changing. So those things also will be monitored. So this is Lagrangian approach. So in this approach, main thing is what? You are studying the particle. You are studying the particle with the time as it is moving. okay, as it is moving. And we'll understand Eulerian approach, then you will get the difference. Okay. So see here, in case of Eulerian approach, so you can see this is Eulerian approach, study at fixed station in space. So in case of Eulerian approach, what we can do is we can take a cut section at the entry or in the middle or at the end at fixed place or at fixed space. We are studying the particles at that place. We are not studying as the particle is moving. We are not following the particle. What we are doing is we are at a particular place. Okay, let's say we are in the middle somewhere here. So we will measure the properties of the fluids when they enter here. So here in the Lagrangian approach, particle is followed everywhere. But here we are considering a cross section or like one plane. There we are measuring the fluid particles which are moving or which are entering that cross section. That is the main difference. Okay. So you can see one example is given here. To know the attributes of a vehicle to be purchased, you can follow the specific vehicle in traffic flow all along its path over a period of time. Okay. Difficulty in tracing the fluid particle makes it nearly impossible to apply the Lagrangian approach. So it is difficult to follow the fluid particle everywhere. If you consider say fluid particle in a lake or wherever, it is continuously moving. So it is very difficult to track that particle and measure the particle properties at each some distance. It becomes very difficult. So that is why Eulerian approach is feasible. Practically, Eulerian approach is feasible, but Lagrangian approach, as the particle is moving anywhere in all the direction, it is very difficult to trace it and measure its properties. But in case of Eulerian approach, like we are at a fixed space or we are at a fixed cross section, we can easily track the properties of the fluids at that cross section. Okay. So we can see here the alternative approach called Eulerian approach consists of observing the fluid by setting up a fixed stations or sections, or as we are mentioning, cross sections in the flow field. So that is shown in figure 2. Like you can take a section here, you take a section here, or you take a section here, or you take section anywhere, and at that section you study the properties of the fluid. The properties of the fluid, like what is its velocity, what is its acceleration, these properties you can study. Okay. Motion of fluid is specified by velocity components as functions of space and time. Okay. So why it is function of space and time? Because we know velocity is given by meter per second. Okay. So as a particle travels some distance, it is traveling in the space, and the particle is taking some time, maybe say 1 minute or 10 minutes or some time to travel that distance. So that is why velocity is usually a function of space and time. Okay. This is considerably easier than the previous approach followed in fluid mechanics. So here, considering the Eulerian approach, when we compare Eulerian to Lagrangian, Eulerian becomes much easy, practically feasible. But if you consider Lagrangian, it is like imagine it is not like, as example was given, car is moving in the traffic. It becomes very difficult to track the properties of that particular car, its velocity, its acceleration, and other properties. But at a particular point, if you are measuring the speed of a vehicle or n number of vehicles, you can easily measure the speed or acceleration or any other properties. Correct? So when fluid is moving continuously, it becomes very difficult to measure all the properties. So that is the limitation. So Eulerian approach is comparatively found easy, practically feasible compared to the Lagrangian. Okay. So here one example is given for Eulerian, observing the variation of flow properties in a channel like velocity, depth, etc. at a station. So here what is done is, it is different types of fluid flow. So it is kind of water flowing in a channel. So you can consider this as a dam kind of structure. Okay, so water is flowing from this in the positive x direction. So you can see there is a section taken one. This is section 1, this is section 2, this is section 3, and this is section 4, and this is section 5. Okay. So these are different types of flows. This is example for different types of flows also. And you can measure, you can say, see, if you want to measure the properties at section 1, it is possible. It is possible by using different measuring instruments, And we are going to study those measuring instruments also in the later part of the course. So at section 2 also we can study the measuring, using the measuring instruments, all the fluid properties. Okay, so you can consider that this is a dam kind of structure. So why this is built? In order to store the water and use it for later purpose. Okay, even a dam is built to generate electricity or to convert the potential energy of water into electrical energy. If I use the word generate electricity, that may be wrong, because we are just we know that energy cannot be created or it cannot be destroyed. We are converting one form of energy to the other form of energy. So this basic simple rule we should know. Okay, yes. So next we have classification of flows. So there are different types of classification with respect to flows. We have steady and unsteady flow. Okay, first one, we have also a uniform and non-uniform flow. Okay, and we have different types of flows. Uniform and non-uniform is also there. Okay, then we have one-dimensional, two-dimensional, three-dimensional flows. Okay, also we have laminar and turbulent flows, compressible and incompressible flows, rotational and irrotational flows. So there are different types of flows. In the examination, they will ask you to either like differentiate between steady and unsteady flow, and say uniform and non-uniform flow. Or in the exam, it will be asked to write down about different types of flows. Explain in brief. So I have to list the types of flows and explain them one by one. So yes, can anybody tell me what is steady flow? What is steady flow? In general definition, not specific one. In general definition, what can be a steady flow? If you know the meaning of the word steady, you can easily define it. Yes, any one of you?
The fluid flow in a definite path.
In a definite path. Okay. Anybody else?
Constant flow of fluids.
Constant flow of fluids. Okay. Try to like define with respect to, consider the meaning that steady. What do you mean by steady? Then try to define. Then you will get like very near to the answer.
Particle of the fluid in flow at any point is same.
Uh, okay. Like here, the properties of the fluid, they are not changing with respect to time. They are not changing with respect to time. Steady means what? Steady means change is not happening. It remains same. So it remains same with respect to time. So if I am studying, say, a fluid particle, if its properties are not changing with respect to time, if the fluid particle properties are not changing with respect to time, then I call that flow as steady flow. That flow as steady flow. Okay, so here what you can imagine is at section 1, you are studying the properties of the fluid particles. You are studying the properties of the fluid particles at different time. Now, if you are measuring at say 1 p.m., let's say the velocity is 10 meters per second. At again 1:10 p.m., if you are measuring the velocity, again it is coming out to be same value. Again, after some time, it is same value. So velocity is not changing with respect to time. Means the flow has attained a steady. Okay, a flow has attained a steady point. Further, there is no change. Okay, until and unless there is some obstruction or there is some like a dam. So before this, the flow you can consider it to be steady almost. So near the dam, the flow cannot be steady. Why? Because the obstruction is there. Once the fluid goes and hits the obstruction, what happens? The properties will change. Definitely the velocity will change. Is that correct? So I can say 1 and 2 sections, we have steady flow. Near this section 3, the flow properties will change. Especially, it will not be steady. Okay. So the definition is simple. A flow is said to be steady if the properties of the fluid and flow do not change with time t at any section or at any point. Correct? So with respect to time, at any section 1, the fluid properties are not changing. You can measure at 1 p.m. or you can measure at 2 p.m. The velocity at that point, it will remain to be same only. Okay. Unsteady means what? The other way. So you just change that. It doesn't change. Do not change. You can change this to the property will change. So this has to be replaced. That is the definition of unsteady flow. Okay. And how it is written in the form of an equation. Here you can see dou by dou t. Here P indicates properties of fluid. Dou by dou t with respect to P. If you differentiate, it will be 0 because we are considering the properties are not changing. Properties are not changing means what? It becomes a constant. With respect to time. Variable is time here. Variable is not other. Like it is not distance. Here we are considering variable to be time. So if you differentiate property P with respect to time, as they are not changing. If they are not changing, they are constant. So the differentiation will come to be 0. Correct? So this is the mathematical way of representing steady flow. Next, unsteady flow. A flow is said to be unsteady if the properties, this P of the fluid and flow change with time. Okay, so here they are not changing, but in case of unsteady, they change. They change with time at any section or any point in a fluid flow. So that means the P, the property P is not remaining same with respect to time. So it is changing. It is a variable now. Okay, at a particular section, it is constant, but at some other particular section, it is changing. So at that section, it is said to be unsteady. Okay. Yes. So there is an example here. Flow observed at a dam section during rainy season, wherein there will be lot of inflow with which the flow properties like depth, velocity, etc. will change at the dam section. Okay, over a period of time, representing it as unsteady flow. Correct. So here it is mentioned near the dam section, as rain starts. What happens? The dam depth will be there. So in summer season, the water will be drained out. No, the depth will go down. But with rainy season, what happens? It starts filling up. And it comes up. Once the dam is full, what they will do? In order to prevent damage, they will open the gates of the dam. So the depth is changing here. The property is changing. The depth is changing. Even the velocity of fluid will change because continuously the water will be coming into due to rain. correct? So yes, any doubt you have?
Sir, inflow means
Inflow means, see, here we in Belgaum, which where we are storing water? Can anybody tell me? In
Rakascop
Belgaum,
dam.
Rakascop dam. So how the water will go to that water Rakascop dam? From anywhere, no? Wherever there is path,
Yes,
so
sir.
water is going into the dam. So that is nothing but inflow. That
Okay,
is
sir.
nothing but inflow. Correct, no?
Yes, sir.
So you see, you have seen that when the dam level is full, when it reaches peak, what they will do? They'll try to open the gates so that damage is prevented. Not even in Rakascop. It is true everywhere. If it starts overflowing, then what happens? The water will flow randomly anywhere. That may create problem. That may create problem. Okay. Yes. Next we have uniform and non-uniform flows. A flow is said to be uniform if the properties P, again we are using this symbol P, it means properties of the fluid do not change with direction. So earlier it is said to be time. Earlier the like we are differentiating with time. Now we'll be differentiating with direction, or even to that matter x direction, y direction, or any direction. Okay, it is not that only x direction, it can be y direction or z direction also. So if the fluid properties are not changing with respect to direction, then that means that is a uniform flow. In a particular direction, if the fluid properties are not changing, that means it is uniform flow. Okay, if they are changing, if the fluid properties are changing with direction, that is non-uniform flow. That is non-uniform flow. Okay, so here it is just written x. The direction they have considered x. It can be y also. It can be z also. Okay, just I'll read out. You'll get to know the meaning. A flow is said to be uniform if the properties P of the fluid and flow do not change with direction over a length of flow considered along the flow at any instant. So you define, say, 1 meter length in x direction. In that 1 meter length, in the particular x direction, if the properties of the fluid and flow is not changing, that means that is uniform flow. That is uniform flow. If this condition is not true, if this condition is not true, then that is automatically non-uniform flow. That is automatically non-uniform flow. So earlier we defined this property with respect to time, and we said that is steady flow. Now we are defining this property with respect to direction, and we are considering a particular length. So here dou by dou x, the parameter P or the property P, if it remains same, then the differentiation will go to 0. Correct? So you differentiate any dou by differentiate a constant. No, if you differentiate a constant, what you will get? 0. Constant means what? It is not changing. So if you differentiate a variable, it will not be equals to 0. Variable means what? That property is changing, that parameter is changing. Okay, so this is how we write it in in the form of equation. Okay, here if you see, a flow is said to be non-uniform if the property is P of the fluid and flow change with direction. Again, it is over a length, over a particular length, over a length of flow considered along the flow in at any instant, at any instant. Okay, so in uniform and non-uniform flow, we are talking about direction. We are talking about direction. So it can be x, y, or z direction, and we are considering a particular length, say 1 meter, 10 meter, or anything. And if the properties are not changing in that particular direction over a defined length, you can measure at any time. You can measure at any instant. Any instant means any time. The properties should remain same. But if the properties are changing, then that is non-uniform flow. That is non-uniform flow. Okay. So the same for that example is given here. Example is given here. Okay. Then we have next one. one-dimensional, two-dimensional, and three-dimensional flow. One-dimensional, two-dimensional, and three-dimensional flows. So can anybody just like tell what is one-dimensional flow? We know no, one-dimensional means what? Only in x direction. Two-dimensional means y direction. Three-dimensional means x, y, z. All the three will be involved. Now, can anybody just try to define this one-dimensional flow in your own words? Maybe right or wrong. Just try to define.
It flows only one direction.
Okay, correct. Anything else? Somebody wants to add something to that? Yes, somebody wants to add to that? Okay, it is very easy. See here, one-dimensional means what? Flow is said to be one-dimensional if the properties vary along one axis. One axis means only x-axis, the properties are changing. Either it can be x-axis or it can be y-axis or it can be z-axis. Understand this. The properties are changing only in one direction. Okay, if properties are changing in x direction, that means in y and z direction, the properties will not change. Will not change means they will remain same in y and z direction. Okay, if the properties are changing in y direction, imagine if the properties are changing in y direction, then they will remain same in x and z direction. So that is one-dimensional flow. That is one-dimensional flow. What is two-dimensional flow? Two-dimensional flow means the properties will vary in x and y direction. The properties will vary in x and y direction, but they will remain same in z direction. They will remain same in z direction. That is what two-dimensional flow. Then what is three-dimensional flow? Three-dimensional flow means the properties will change in x direction, okay, y direction, z direction. Means the properties are changing in all the direction. The properties are changing in all the direction. Okay, so just we will read out so that you will get a better understanding. Flow is said to be one-dimensional if the properties vary along one axis or direction and will be constant with respect to other two directions of the three-dimensional axis system. Three-dimensional axis system. Okay, so this is one-dimensional flow. What is two-dimensional flow? Flow is said to be two-dimensional if the properties vary along two axes. Here it is not AXIS, it is AXES. Two-dimensional axis or direction and will be constant with respect to the other direction of the three-dimensional axis system. Means here, if x and y, in x and y direction, if the properties are changing, in z direction, the properties will remain same. Okay. If say that y and z direction, the properties are changing. In x direction, the properties will remain same. Okay. Again, properties means what? We are talking about velocity, okay, or say depth, height, okay, or even to that matter acceleration. These are the properties. Okay. What is three-dimensional flow? Flow is said to be three-dimensional if the properties vary along all the axes. All the axes. Again here, axis is plural, more than one. Axis or directions of the three-dimensional axis system. Three-dimensional axis system. So three-dimensional means what? X is changing, Y is changing, Z is changing. All the three are changing. All the three are changing. Correct? Means in all the three directions, properties are not remaining constant. They are continuously varying. They are continuously varying. Okay? So that is a three-dimensional flow. Okay? So in one-dimensional flow, if you are considering say one-dimensional flow, you need not concentrate on Y and Z. Just you study x-axis. Just you study x-axis. That is sufficient. You study the properties in x-axis with respect to the fluid. You need not study with respect to y and z. Why you need not study? Because they are remaining same. That approach is known as one-dimensional study approach. If you study just one dimension, that is sufficient. Because as per the assumption or as per the given data, the properties are changing only in x direction. Correct? So there is no point in studying the properties in y and z direction, because they are remaining same. They are not varying. They are constant. Okay? So that is one-dimensional, two-dimensional, and three-dimensional approach, or one-dimensional, two-dimensional, three-dimensional flow. Okay? Yes, this one I think you know it. Laminar and turbulent flow. This one you know it. Can anybody just tell me what is laminar and turbulent flow? That I think I should not explain, that you know it already, because you have studied it from your like school level or prior to that. Maybe I think in engineering also somewhere I have studied this. Can somebody recall and tell me what is that laminar and turbulent flow?
So laminar flows are those flows which are goes in a straighter, and turbulent which goes in a zigzag way.
Okay. Okay. Yes. It is almost correct. Can somebody just refine it? 99% you are correct. What he said is correct. Yes, anybody wants to refine it? Actually, in case of laminar flow, we define a certain parameter called Reynolds number. It is a non-dimensional number. Reynolds number, a non-dimensional number. Okay. So in case of that laminar flow, if it is a laminar flow, as you said, the fluid particles will be flowing in a straight line. Will be flowing in a straight line. They'll not flow in zigzag manner. If they start flowing in zigzag manner, then that we consider it to be turbulent. But if you define it like this, it is also correct, but you will not get full marks. In order to get full marks, what we have to do? We have to use this Reynolds number. If the Reynolds number is less than 2000, when we are considering a pipe flow, pipe flow means what? Now in our home, that the water from the tank, it comes to the tap when you open the tap. That is a pipe flow. Okay, that is a pipe flow. And again, water will be flowing on some surface. That is another case. So usually when we are defining this one, no, in particular case, we are considering there is a pipe of certain diameter. Okay, there is a pipe of certain diameter. The fluid has density rho, and it will be moving with a certain velocity in the pipe, and mu is the viscosity of that fluid. So considering all this, if you calculate Reynolds number, if it comes out less than 2000, then in that case we consider that flow to be laminar flow. Automatically, if the Reynolds number comes less than 2000, the particle will be moving in a well-defined way. They will be moving in a smooth, in a straight line, or in a streamline. They will not be moving zigzag. Okay, this is laminar flow for you. Okay, so I'll just read it out. When the flow occurs like sheets or laminates, and fluid elements flowing in a layer does not mix with other layer. Correct? So let's say fluid particles are moving in one line, they will not mix with the fluid which are flowing in the other line. So that is why it is mentioned sheets or laminates. Then the flow is said to be laminar. The Reynolds number Re for the flow will be less than 2000. So if you write just the flow will be in a streamline, then you will not get full marks. In order to get full marks, what we have to do is we have to write this compulsory Reynolds number rho Vd by mu less than 2000. Re less than 2000 will give you that laminar flow. Okay, and if the Re number, when we calculate it, comes out to be greater than 4000, then the flow is said to be turbulent. turbulent. In case of turbulent flow, what happens? All the layers will mix with each other, and there will be random zigzag flow. There will be random zigzag flow. That is known as turbulent flow. For the case of turbulent flow, Reynolds number will be greater than 4000. Greater than 4000. Okay. Less than 2000 is laminar. Greater than 4000 is turbulent. But what about between 2000 and 4000? Between 2000 and 4000, there is something happening, no? So that flow, we define it as transition flow. That flow, we define it as transition flow. Okay. Just I'll read out, you'll get to know. When the flow velocity increases, the sheet flow gets mixed up with fluid elements, mixed with other layers, thereby causing turbulence. Okay, there will be eddy currents generated, and flow reversal takes place. This flow is said to be turbulent. Okay, in case of turbulent flow, all the particles will be moving in a random direction, in zigzag way. So one layer of the fluid will be mixing with other layer of the fluid. Why this happens? Because in this turbulent flow case, the velocity will be higher. The velocity will be higher. Try to understand. The density of water, will it change? The density of water is 1000.
No, sir.
It cannot change. Okay, which parameter can change? Only velocity can change. Can the diameter of the pipe change? It cannot change. It will be fixed. Water will be moving in a pipe whose diameter is fixed. Diameter cannot change. Can the viscosity of the water can change? It can also never change. With respect to temperature, it will change. But we are talking about when the temperature is same. So which parameter is causing the main change in the Reynolds number? That is velocity. That is velocity of the water. Okay. So if the velocity of the water increases, then the flow changes from laminar to turbulent. Try to understand this point. It is very important. That is why it is used here. Velocity increases when the flow velocity increases. Because we know density is same, diameter is same, and viscosity is also same. Okay. So this is turbulent flow. Then we have the Reynolds number for the flow will be greater than 4000. That is turbulent flow. Okay. Then for flows with Reynolds number ranging between 2000 to 4000 is said to be transitional flow. Transition means what? There is a change from laminar to turbulent. The fluid flow is changing from laminar to turbulent. So in the range of Reynolds number 2000 to 4000, there is transition happening. There is transition happening. So that is why it is defined as transition flow. That is why it is defined as transition flow. Okay. Yes. So I think that's all for the day. If anybody has missed out your attendance, you can give it now. I will take it. Those who have missed, simply others don't repeat because already we have noted. Okay, those who have noted, you can go and attend the other class.
Sir, C08.
Okay, C08. Noted down. Anybody from A division or B division or C division, you can mention your name. Somebody has written B8. B8. B8 is there. Okay, anyways, I have noted down the number B8. Okay, thank you everybody. You can attend the other class.
Thank you, sir.
Thank you, sir.
Thank you, thank you. Here somebody is writing 2707. C27 noted down. 07 noted down. 23. A23. A23 is here. Jason logo. Anyways, I have noted down A23.